So what if I told you that a regular, everyday egg could take a bath in super strong acid and come out completely fine? We're going to dive into a really bizarre experiment today, one that seems to just totally break the rules of chemistry as we know them.
All right, take a good look at this egg. That darker half was dunked in a seriously powerful acid for a full 24 hours. And what you're seeing here, the result, it isn't just a little surprising. It kind of feels like it challenges a basic law of science that, we all learned back in school.
The solution this egg was sitting in had a pH of 0.5. Now, to give you some perspective, that is way more acidic than your own stomach acid. We're talking about an environment where complex stuff like an eggshell, well, it just shouldn't be able to survive.
So, according to all the science we know, what should have happened? Well, the answer is pretty straightforward, and believe me, it looks nothing like that first picture we saw.
Just look at this breakdown. On the left, that's what Science 101 predicts, right? A violent fizzing reaction, the shell dissolving into a bubbly mess. But then you look to the right, and that's what actually happened in the experiment. The shell, it stayed totally hard, and instead of dissolving, the brown pigment just sort of peeled off. Wild.
And the people who saw this happen, they knew right away how huge this was. They called it a singularity event, which is basically a fancy way of saying the result was so unexpected, it just shatters the fundamental rule of science. It was a huge clue that something brand new was going on here.
And that brings us right to the core of this whole mystery. How in the world can an acid this strong just not dissolve a simple eggshell? I mean, eggshells are made of calcium carbonate, which is basically candy for acids.
So here's the twist. The answer isn't a lack of power. It's not like the acid was watered down, no. The answer is an absolutely incredible level of precision. This stuff isn't just using brute force. It's almost like it's intelligent. It's choosing its targets. The technology here is based on a principle they call selective reactivity. Think of it this way. It has the amazing ability to tell the difference between something you want to get rid of, like the brown pigment, and the essential stuff underneath, like the actual shell. And it only goes after the part you don't want.
So how does it actually pull this off? Well, it's this really cool two-step dance. First, there's something called the proton shell. It basically puts the acid's power, the protons, inside a tiny cage of water molecules. That cage stops it from dissolving the mineral shell. But then, and this is the smart part, it has this high electrical energy, kind of like a tiny targeted shock, that specifically zaps the bonds holding the organic pigment onto the shell. And poof, it just lifts right off.
Okay, protecting the shell is one thing. That's incredible. But what about the fragile life inside? A pH 0.5 solution should absolutely cook the proteins, right? It should turn the egg white and yolk into a solid rubbery mess.
But you guessed it, that is not what they found. It's amazing. When the scientists cracked the egg open, it was completely, perfectly normal. Just a fresh, raw egg inside, like nothing had ever happened to it.
And this image right here is the proof. This might be the most mind-blowing discovery of the whole thing. Even in that insanely acidic environment, the liquid never got through the shell, never harmed the living cells inside. It's just a powerful visual confirmation of how safe this technology is. All right, so a clean egg. Cool science trick. But what does this strange experiment actually have to do with us? How does a breakthrough like this actually translate into our world? Well, you should care. Because the ability to tell the difference between a base material and some gunk you want to remove from it, that has massive, potentially world-changing implications. The egg is really just a proof of concept. See, that eggshell is a perfect stand-in for other sensitive surfaces. Think about your teeth, for example. The shell is like your enamel, and the pigment, well, that's like coffee stains or tartar. Or what about your skin? The shell is your living tissue, and the pigment is that layer of dead cells you want to exfoliate. Let's just take dentistry. Right now, most whitening methods use gritty, abrasive stuff that literally grinds down your enamel, and getting tartar scraped off can be really painful. This technology, though, it could just lift the stains off and weaken the tartar's grip so it comes away easily, all without damaging the enamel. That could be the end of tooth sensitivity from cleanings. Now let's apply that exact same logic to skincare. We use things like chemical peels that basically burn off the top layer of skin, and that's why you get redness and irritation. Now imagine a peel so precise it only removes the dead cells, leaving the healthy, living skin underneath completely unharmed. That would be an absolute game changer, especially for people with sensitive skin. You know, all of this makes you take a step back and ask a much bigger question. If this stuff doesn't act like a normal acid,
then maybe, just maybe, it isn't one. And that's exactly what the scientists looking at this concluded. They basically said, you know what? Calling this an acid is just wrong. It's missing the whole point. It's much more accurate to describe it as a kind of intelligent energy, delivered through water.
So what we're really looking at is a whole new category of substance. It solves a complete paradox. It has the incredible cleaning power of a strong acid, but at the same time, it has the safety and gentleness you'd expect from pure water. This one little experiment on an egg really just blows the doors open to a universe of new possibilities. It forces us to imagine a future where we can clean, heal, and preserve things with absolute precision, changing everything from how we take care of our bodies to how we protect priceless historical artifacts. It makes you wonder, what else could we solve with this kind of intelligence?